Hello students, in previous class we have seen how to find equation of a circle and what is the general equation of a circle and some other basic properties of that one. And let us see what are the notations we will use throughout this chapter. We have seen general equation of a circle as x square plus y square plus 2gx plus 2fy plus c equal to 0, and this we will denote it with s. And notation S1 is there, xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c. That is, whenever if we come across this expression xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c, we will denote it with S1. S11 x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. It is a notation. Whenever if we come across this expression, we will take it as S11. And S12 is there, x1 x2 plus y1 y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c. These are the notations we are going to use throughout this chapter. Of course, one or two notations might have, different notations in other books, but in our lectures throughout this topic, we are going to use these notations only. This general equation expression, it is denoted by S. S1 means here is xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c. S11 means just substitution of x1 comma y1 in this equation of the circle. This is denoted by S11, and S12 means x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. Now, let us see the concept position of a point. What does it mean? What is the position of a point mean? Suppose if I take any circle, if I take any point P in that plane, what are the possibilities for this plane? It may lie here, or it may lie on the circle, or it may be inside the circle. This region is called, interior of the circle, and this is outside of the circle means exterior of the circle, and this is circumference of the circle. When this point P lies on this means we can say it is a point on the circle, and if P lies here means we can say P lies outside of the circle, and if it lies inside means P lies inside the circle. And how to check for a given point whether it lies inside or on the circle or outside the circle? Let us take equation of the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0, and let us take point P as x1 comma y1. Case 1, if P lies outside of the circle, that is somewhere here if I take P whose coordinates are x1 comma y1. Let C be the center. If I take this is the circle equation, we know center is minus g comma minus f. It is minus g comma minus f. And if I join these 2 points now, clearly you can observe this distance CP is greater than that of this distance radius of the circle. Therefore, here I can write whenever P lies outside the circle, the distance between center and that point P is definitely greater than radius. Cp greater than radius means we can write Cp square greater than r square, and you know here what is r? R is radius of the circle, square root of g square plus f square minus c. Cp square is a distance between those 2 points only, that is Cp square greater than r square, x1 plus g whole square plus y1 plus f whole square is greater than r square means g square plus f square minus c. Or that implies, if I open this, x1 square plus g square plus 2gx1 plus y1 square plus f square plus 2fy1 is greater than g square plus f square minus c. You can observe here g square will get cancelled, f square will get cancelled. Finally, it is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c greater than 0. But we know this notation for this is S11. That implies if I use this one, S11 greater than 0. Therefore, whenever a point lies outside of the circle, if I take notation of the circle as S, then if I substitute x1 comma y1 on the circle, that should be positive. Whenever S11 greater than 0 means we can say point lies outside of the circle. Case 2, if P lies inside the circle, if I take inside the circle means if I take this is the circle and here it is the center, somewhere if I take P, if I join this one, definitely complete this is R. In this case I can write Cp distance is less than that of radius of the circle whenever P lies inside the circle. Implies Cp square greater than, less than r square, and exactly here Cp square greater than r square means that simplification we got it as greater than 0, and if I simplify it, I will get it as x1 square plus y1 square plus 2gx1 plus 2fy1 plus c less than 0, and this is S11 less than 0. Therefore, if the point lies inside the circle, then S11 value less than 0. And case 3, it is when P lies on the circle. On the circle means it has to satisfy the equation of the circle. Therefore, if I substitute x1 comma y1, I will get S11 value must be equal to 0. It is obvious that the value of the circle, when you substitute that point which lies on that circle, definitely it should be equal to 0. Therefore, here position of the point once again you see. If you take any circle, possibilities for any point may be outside of the circle or inside the circle or on the circle. And how to check when a point is given and a circle is given, whether it lies outside or inside or on the circle means, it is the method when Cp greater than R means outside. On simplification we will get S11, where S11 is nothing but x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Therefore, whenever S11 greater than 0, then point lies outside the circle, and whenever S11 less than 0, then point lies inside the circle, and whenever S11 equal to 0, then that point lies on the circle. It is about position of a point with respect to a circle. Suppose it is the circle x square plus y square minus 2x minus 4y plus 3 equal to 0, and let us see position of the points. First point I will take 0 comma 0, and second point I will take 1 comma 1, and third point I will take minus 1 comma 3. Let us check position of these points with respect to the circle. I will find S11. S11 is nothing but simply substituting this point on that circle only. What is the notation here? It is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. If I substitute 0 comma 0 here, I will get 0 plus 0 minus 2 into 0 minus 4 into 0 plus 3. It is equal to 3, which is greater than 0. Since S11 greater than 0, that implies I can write this point 0 comma 0 lies outside of the circle. Next, we will see for this point 1 comma 1. I will find S11 for this one. Therefore, if I substitute 1 square plus 1 square minus 2 into 1 minus 4 into 1 plus 3, it is equal to 2 plus 3, 5 minus 6 is equal to minus 1 less than 0. And since S11 less than 0, that implies I can write this point 1 comma 1 lies inside the circle. If I take third one minus 1 comma 3, let us check whether it lies inside or outside or on. If I find again S11 for this, 1 square plus 3 square minus 2 into minus 1 minus 4 into 3 plus 3, it is equal to 9 plus 1, 10 plus 3, 13, 12 minus 12 plus 2 minus 10 is equal to 3 greater than 0. Therefore, even this point minus 1 comma 3 lies outside of the circle. Therefore, simply substitute that point in the equation of the circle and check whether it is greater than 0 or less than 0 or equal to 0, and then you can decide whether this point lies outside the circle or inside the circle or on the circle. Next point, suppose S equal to 0, equation of a circle, and L equal to 0 is any line which intersects circle, then equation of circle passing through points of intersection of S equal to 0 and L equal to 0 is S plus lambda L equal to 0, where lambda is a parameter. It comes under family of circles. Of course, in detail we will discuss about this S plus lambda family of circles in coming classes, but this point we are going to use this concept in further problems. Therefore, we are going to discuss a little about this now. While learning straight lines, you have seen family of lines. If L1 equal to 0 and L2 equal to 0 are any two intersecting lines, then equation of any line passing through that point of intersection is of the form L1 plus lambda times of L2 equal to 0, and you know that this L1 plus lambda into L2 equal to 0 is represents family of lines passing through point of intersection of L1 equal to 0 and L2 equal to 0. Therefore, in the similar way, if I take any circle S equal to 0 and a line L equal to 0 is there which intersects with the circle. Suppose if I take it is L equal to 0 and S equal to 0. Let us take these points of intersections are A comma B. Now any circle passing through points of intersections of this circle S equal to 0 and L equal to 0. How many circles are possible? Actually infinitely many circles are possible which are passing through these points of intersections, and any circle can be represented in the form S plus lambda L equal to 0. We will see 1 minute how exactly this will be. Let me take S as x square plus y square plus 2gx plus 2fy plus c, and L, let me take that line as Lx plus my plus n equal to 0. What is S plus lambda L equal to 0 you see? That implies x square plus y square plus 2gx plus 2fy plus c plus lambda times it is what Lx plus my plus n equal to 0, or x square plus y square plus 2g plus lambda L into x plus 2f plus lambda m into y plus c plus lambda n is equal to 0. Now observe here. Now it is a second degree equation where coefficient of x square and y square both are equal, and coefficient of x is there, coefficient of y and constant term, there is no xy term. Yes, it represents a circle. When I can say it is passing through this point of intersection A and B, only when A and B lies on this equation, means lies on this equation S plus lambda L equal to 0. Observe this. A is point of intersection of S equal to 0 and L equal to 0, means A lies on S equal to 0 and A lies on L equal to 0. Therefore, if I substitute A, this will become 0 and it will become 0. Therefore, clearly we can say A lies on S plus lambda L equal to 0. Observe, because A is a point on S equal to 0 as well as A is a point on L equal to 0. The moment if I substitute this point in this equation, it will become 0 plus lambda into 0, therefore total equal to 0. Hence, we can say A is a point on S plus lambda L equal to 0. And similarly, B is the intersection of S equal to 0 and L equal to 0. It lies on S equal to 0 and L equal to 0. Therefore, even we can say B lies on S plus lambda L equal to 0. Because the moment if you substitute B in this equation, because it lies on S equal to 0 means it will become 0 and it will become 0. 0 plus lambda into 0 means it is equal to 0. Hence, both the points A and B lie on S plus lambda L equal to 0. That is this equation. It represents a circle and it is passing through A and B. Therefore, we can say the equation of the circle passing through point of intersection of S equal to 0 and L equal to 0 will be of the form S plus lambda L equal to 0, and for different values of this parameter lambda, we will get different circles which are all, we can say, members of that family which are passing through these points of intersections. Now, we will see one problem on this. Suppose x square plus y square minus 2x minus 4y minus 4 equal to 0 is the equation of circle, and x plus y minus 2 equal to 0 is the equation of line. Now, we want find equation of circle passing through points of intersection of S equal to 0 means circle and L equal to 0 means line, and also passes through a point 3, 0. What they are asking is, circle is given, line is given. We need equation of line passing through points of intersection of circle and line, and also passing through a point 3, 0. Let us take this is the circle equation, and suppose it is x plus y minus 2 equal to 0, and these are the points of intersection. So, let it be A and let it be B. Now, our job is to find equation of circle which is passing through these points, intersections, and of course, now infinitely many circles are possible, which are passing through points of intersection of S equal to 0 and L equal to 0. I want one of those circles only, and along with this A comma B, and a point is there that is passing through 3, 0 also. Now, using the concept just now we have seen, equation of any circle belonging to that family can be written as S plus lambda L equal to 0. What is S here? X square plus y square minus 2x minus 4y minus 4 plus lambda times x plus y minus 2 equal to 0. It is the family of circles. Now, because it is passing through 3, 0, to find this parameter lambda, they have given another condition that our required circle is passing through 3, 0. Therefore, substitute 3, 0 to find value of this lambda. That is 9 plus 0 minus 6 minus 0 minus 4 plus lambda times 3 plus 0 minus 2 is equal to 0. 9 minus 10 minus 1 plus lambda times 1 is equal to 0. That implies lambda equal to 1. Now, from 1 if I take lambda equal to 1, this equation will become x square plus y square minus 2x minus 4y minus 4 plus 1 into x plus y minus 2 is equal to 0. That is x square plus y square minus 2x plus x minus 4y plus y minus 3y minus 4 minus 2 minus 6 is equal to 0 is the equation of the required circle. Now, let us move to the next point, next concept. How to find equation of circle when it is passing through 3 non-collinear given points. 3 non-collinear points means always a triangle can be formed. Now, we need to find equation of the circle passing through those 3 points, means this circle we want, we can say it is the circumcircle of this triangle also. If I take this as A, it as B, it as C, now circumcircle of that triangle ABC we need to find. How to find this equation of circle when it is passing through 3 given points? We will see 3 or 4 methods one by one. Suppose A x1 comma y1, B x2 comma y2 and C x3 comma y3 are 3 given points. Now, let us see method 1 to find equation of the circle that is passing through these 3 points. What is the method 1? You see, general method. I will assume circle equation as, let the equation of circle be x square plus y square plus 2gx plus 2fy plus c equal to 0. Now, here how many unknowns are there? 3 unknowns, g, f and c. These are the parameters. If we are able to find g comma f comma c, we can substitute them here and we will get equation of the required circle. Given that this circle is passing through 3 points, what I will do, you see this method, I will substitute A x1 comma y1 in this equation. Now, I will get one relation in terms of g comma f comma c, let it be equation 2. You know how to substitute a point in the circle. Similarly, I will substitute bx2 comma y2, and again we will get one more relation in terms of g comma f comma c, let it be equation 3. And in the same way, I will substitute cx3 comma y3, I will get one more relation in terms of g comma f comma c, which is equation 4. Now we have 3 equations and 3 unknowns, and we can solve these 3 equations to find g comma f comma c. Now solve 2 comma 3 and 2 comma 4 or 3 comma 4, and you can find g value, f value and c value. Now after finding these values, we can write equation of the circle. First I will explain the methods, then we will see problems. How to do, solve by using these methods we will see. So once again you see, it is method 1, general method. I have taken equation of the circle as general equation. Here g comma f comma c 3 unknowns are there, and if we get these values g comma f comma c values, then we can substitute them to find that equation of the circle. As it is passing through these 3 points a comma b comma c, first I will substitute ax1 comma y1. When if you substitute x1 comma y1 here, which is a given point, I will get one relation in terms of g comma f comma c. And again x2 comma y2, one more relation in terms of g comma f comma c. And x3 comma y3, if you substitute, one more relation in terms of g comma f comma c. You all know that 3 equations are there and 3 unknowns are there. We can find g comma f comma c by solving these equations. Solve them and find g comma f comma c, and again if you substitute them in this equation 1, we will get equation of the required circle. Now we will see a second method. As it is passing through 3 non-collinear points, let it be A, and here it is B, and here it is C. As already we have discussed, this circle is nothing but circumcircle of this triangle ABC. And in straight lines, we are familiar with finding circumcenter of a triangle, which is nothing but center of that circle only. Let us take S be the circumcenter, and whose coordinates are alpha comma beta if I take. Observe, if you find S coordinates alpha comma beta, that is the circumcenter, then it is over. We can write equation of the circle, because we know center of the circle, and since it is the center of the circle, distance from S to any of these 3 points will give radius only, all are equal. Therefore, we can find radius, center we know, radius we know, we can write equation of the circle. Now, how to do this one? Because it is a circumcenter we have taken, and since A comma B comma C are points on the circle which are equidistant from this S, we can write SA is equal to SB is equal to SC. Now, one equation is SA equal to SB and another equation is SA equal to SC I will take. What is this SA equal to SB you see? If I solve this SA equal to SB, where A x1 comma y1 is there, B x2 comma y2 is there, C x3 comma y3 is there. What are the unknowns here? Only alpha comma beta. Therefore, one relation in terms of alpha comma beta I will get by solving SA equal to SB. Similarly, if I solve SA equal to SC, here also one more relation I will get in terms of alpha comma beta. And here we have one equation and here we have one relation in terms of alpha comma beta. and if I solve these two relations or these two equations, we can find alpha value and we can find beta value, which is the circumcenter of that circle, which is S alpha comma beta we can find. Once if we find alpha comma beta, now I can find a radius. As you know that radius is a distance from that circumcenter to any of those 3 points. Center we know, radius we know, we can find the equation of the circle. We will see another way of handling this problem. Of course, it is almost similar to second one only, but in a different way. Yes, I need equation of the circle that is passing through 3 points, capital A, capital B, capital C. Here what is the concept I am going to use? If you take any circle and any chord of that circle, if you take perpendicular bisector of any chord, perpendicular bisector means a line passing through midpoint and perpendicular to that line is called perpendicular bisector, that you know it. A line passing through midpoint of that and perpendicular to that line is called perpendicular bisector of AB, and perpendicular bisector of any chord passing through its center. This is the concept I am going to use here. Because AB is a chord, BC is a chord, AC is a chord, I will take perpendicular bisector of AB, which is passing through the center. Let me take it as S. And I will take another perpendicular bisector from BC, which is also perpendicular to this and passing through S. Now S is the point of intersection of these perpendicular lines, which is a circumcenter. Let me take this point as a D, this point as E. First of all, you see how to find this perpendicular bisector. Because it is the perpendicular bisector means D is midpoint of AB. It is midpoint of AB. Yes, A given, B given, I can find midpoint. And since this is perpendicular to this, what I will find? I will find slope of AB. If slope of AB is equal to M, then slope of ds will become minus 1 by m. Now to find equation of ds, we know coordinates of d and slope of ds. If we know a point and slope, we can write y minus y1 is equal to, or any point if I take y minus beta is equal to slope means minus 1 by m means into x minus alpha I can take if this point is alpha comma beta. Therefore, it is the equation of ds. Similarly, I can find equation of es also, and when I get two perpendicular bisectors equations, if I solve those two equations, I am going to get point of intersection as center of that circumcircle. And if I know center, as usual, I can find a radius, which is the distance from that point to any one of these three vertices. Center we know, radius we know, we can find equation of the circle. Once again observe this. What is the concept we are using to find circumcenter or center of the circle? Perpendicular bisector of any chord passing through its center. That is the concept we are going to use. Because here 3 points A, B, C are given, if I join A, B, B, C and C, these 3 are the chords of that circle. Because A, B is a chord, I am taking perpendicular bisector. Perpendicular bisector means you all know that it is passing through midpoint and perpendicular to that side. We can find midpoint, slope of AB and hence slope of ds we can find. Therefore, equation of ds I can write. In a similar way, I can find equation of perpendicular bisector of this BC, which is ES also, and I will solve these two equations to find circumcenter, and from that radius I can find, and I can find equation of the circle. Just I am explaining the methods first. We will see problems after completing these methods. Hope you understood this method. And next we will move to next method. Another way of handling this problem. Three points are given. It is A, let me take here it is B, and it is C. Observe. We need equation of the circle passing through these 3 points. Suppose say it is the center of the circle. I will take diameter passing through any one of these 3 points, let it be passing through A, and let me take this point as D. Observe this carefully. Because AD is the diameter, it is a semicircle, it is a semicircle. If I join AB and if I join BD, it is angle in a semicircle, here it is 90 degrees. Therefore, now can we find equation of BD? Yes, we can find equation of BD. I can find slope of AB. Suppose this slope is equal to m. Since BD is perpendicular to AB, slope of this will become minus 1 by m, and B coordinates already given x2 comma y2. Hence, I can find equation of BD. Hope you got this point. Next, in the similar way, if I join this point and join this, again it is angle in a semicircle 90 degrees. In the similar way, I will find slope of this one, let it be m1, because A given x1 comma y1 and C given x3 comma y3, these are the fixed points, given points, we can find slope of AC. Since CD is perpendicular to AC, I can find slope of this, it will become minus 1 by m1. And CD equation, point on CD we know and slope we know, therefore, we can write equation of this CD also. Now, I know equation of BD and equation of CD, and if I solve these two equations, if I take a D coordinates I can find which is the other end of the diameter. Which is the other end of the diameter. Suppose say if it is alpha comma beta, it is alpha comma beta. Now we know ends of diameter of a circle x1 comma y1 and alpha comma beta. In the previous lecture we have seen how to find equation of a circle when ends of diameter are given. If it is x1 y1, it is x2 y2, we have seen x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Even here you can write equation as equation of circle with AB as diameter is x minus x1 into x minus alpha plus y minus y1 into y minus beta equal to 0. This method is interesting. Once again observe, I have taken this circle, 3 points are given A x1 y1, B x2 y2 and C x3 y3. What I have done here is, see, I have taken one diameter passing through any of these 3 points you take, I have chosen A and passing through A, AD is the diameter. I joined AB and BD because angle ABD is 90 degrees. We know slope of this and slope of this will become minus 1 by m, equation of BD I wrote. Similarly, equation of CD I wrote, equation of BD and equation of CD if I solve, I will get D coordinates, which is the other end of the diameter passing through capital A. Now we know ends of diameter, either you can use this formula or midpoint will give center, and AD is nothing but diameter, radius you can find from that, even equation of circle you can write in that way also. Let us see method 5 to find equation of the circle using the concept family of circles. Yes, please concentrate here. It will be a good method. 3 points are given. I will take any two of those 3 points and I will find equation of circle as these two as ends of diameter. As these two as ends of diameter. Now, many circles are possible which are passing through these ends, and of course, AB is the diameter. Here it is one circle passing through this. In fact, many circles are possible. Out of all those circles, we need a circle that is passing through A comma B comma C. Already AB is there. Somewhere C x3 comma y3 will be there. Therefore, now you see, I can say our circle, required circle, is passing through point of intersection of the circle with AB as a diameter and the line AB. Therefore, what I will do, I will find equation of circle with AB as a diameter and equation of line AB I will find. It is of the form L equal to 0, it is S equal to 0. Therefore, now I can say if it is the required circle, it is passing through the point of intersection of this S equal to 0 and L equal to 0, that I can write it as S plus lambda L equal to 0. To find this value of lambda, now what I will do, I will substitute our third point Cx3 comma y3 and I will find value of lambda and I will resubstitute this value of lambda here. Therefore, I will get required circle. See this method? 3 given points are there. You choose any 2 points out of those 3 and write equation of circle with those 2 as ends of diameter, and equation of that line only you find. Here I have taken AB as ends of diameter and I found equation of that circle, and equation of AB I found L equal to 0. Now, S equal to L equal to 0 means family of circles I can write S plus lambda L equal to 0. Therefore, our required circle is also a member of this circle which is passing through points of intersection of S equal to 0 and L equal to 0, and of course, it is also passing through the point x3 comma y3, and substitute this point to find value of lambda, and again substitute that lambda value to find equation of the required circle. Other method we will see. Here a circle, it is a point A, it is a point B and it is a point C given. Yes. We can say it is a chord and these are the fixed points, given points. It is x1, y1 and it is x2, y2 and it is x3, y3. These are the fixed points, given points. I will take another point, general point P, whose coordinates are x comma y. And now, what is the property I am going to use here? If you take any circle and if you take any chord AB, it subtends same angle at any point on the same segment. If I take this angle is theta, this angle also theta. Even if I take here also this angle also theta 1. A chord subtends same angle at any point in the same segment of a circle. Therefore, here BC is a chord. If I take angle subtended by BC at A and angle subtended by BC at P, both are same only. If it is alpha, it is also alpha. Hope every one of you knew this point already. It is same chord only BC. These two are the points on the same segment, same side of this chord. Angle subtended by this chord BC at A and at P both are equal. Now what I will do? Because x1, y1, x2, y2, x3, y3 are given points, I will find slope of AB as m1, slope of AC as m2, and I will find tan alpha is equal to m2 minus m1 by 1 plus m2 into m1. And in a similar way, P x comma y is the general point I have taken on the circle, x2, y2 and x3, y3. I will find slope of PB, let it be m3, and slope of PC, let it be m4. Therefore, again I will find tan alpha is equal to m4 minus m3 by 1 plus m3 into m4. This value is fixed because value of m1 we know, m2 we know, whereas this m3 if you find, what I will get m3? M3 is equal to y minus y2 by x minus x2, and m4 what I will get, it is equal to y minus y3 by x minus x3. Now it is tan alpha and it is also tan alpha, and if I equate them, m2 minus m1 by 1 plus m2 into m1 is equal to m4 minus m3 by 1 plus m4 into m3, and if I solve this equation, we will get equation of that circle only. It is the property that a chord subtends same angle at any point on the circumference. Method 7, by using determinant method. See here, I am not going into complete details about this one. First, I will give you how to write this equation, and I will explain how exactly that one in a nutshell. Therefore, equation of circle passing through capital A comma B comma C is determinant of x square plus y square x y 1, x1 square plus y1 square x1 y1 1, x2 square plus y2 square x2 y2 1, x3 square plus y3 square x3 y3 1 is equal to 0. If you expand this one, you will get a second degree equation that represents a circle. Let us look about this determinant 1 minute. Look here everyone. If I open this determinant, you know how to expand a determinant. 3 by 3 you have seen already. 4 by 4 also, it is like similar to 3 by 3 only, how to write you see. You can expand this determinant along any row or any column. Suppose if I open this one along first row, what I will get you see? X square plus y square into delete this row and this column. Now cofactor of this one means, now I will get determinant of this one only. leave this row and this column into determinant x1, y1, 1, x2, y2, 1, x3, y3, 1, which is a constant only, it is of type A. Next negative sign, minus x into delete this row and this column. All are given values only. Again I will get a constant like B. Next plus sign, y into, again delete this row and this column. Again I will get another constant of the type C. Plus 1 into, again delete this row and this column. Again I will get one more constant only. Plus lambda I will take, it is equal to 0. Observe here, this A, B, C and lambda are the cofactors of these elements. Yes, it is a second degree equation where coefficient of x square and y square both are equal to A, that is both are equal, and x coefficient may be there, y coefficient may be there and constant may be there, and coefficient of xy is not there, it is a circle. And if we observe that it is passing through x1, y1, x2, y2, x3, y3, therefore we can say it is the circle equation which is passing through these 3 points, we can say. Observe this. If I substitute x1 comma y1 in this determinant, means replace x by x1 and y by y1. What you can observe, if I substitute x1 comma y1, it will become x1 square, y1 square, x1, y1, 1. In a determinant, first row and second row are identical. First row and second row are identical means value of this determinant will become 0. Therefore, I can say x1 comma y1 lies on this curve. In a similar way, if I substitute x2 comma y2, now first row and third row will become identical. Therefore, I can say x2 comma y2 identical means that will become 0. x2 comma y2 is also a point on that circle. Similarly, even we can observe for third point x3 comma y3 also. Therefore, this equation represents a circle and all these 3 points a comma b comma c lie on this circle. Hence, we can say it is the equation of circle that is passing through ax1 comma y1 and bx2 comma y2 and cx3 comma y3. Yes, we have seen so many methods here. I have explained to you, to make you thorough with the concepts. Yes, while solving problems, whatever the method it clicks for you and whatever the method you feel easy, that you can apply, that you can use to find equation of a circle. There is no need to apply a particular formula or particular one, whatever it clicks for you. If you are aware of all these methods, happily you can do any problem using, this type of problems easily we can handle it. If you learn number of ways of solving a problem, definitely we will get interest towards the subject and we can handle any problems which are multi-concept type problems also we can handle it. Okay. We will see 1 or 2 problems based on these concepts. Now we will see one problem. I want equation of circle passing through these 3 points 1 comma 1, 2 comma minus 1 and 3 comma 2. Let us take A 1 comma 1, B 2 comma minus 1 and C 3 comma 2. I will take first equation as x square plus y square plus 2gx plus 2fy plus c equal to 0. General method I am taking. What I will do, I will substitute these 3 points to get 3 relations in terms of g comma f comma c and I will solve them to find g comma f comma c and I will substitute here. I will do it. As it is passing through the point a 1 comma 1. 1 plus 1 plus 2g into 1, 2f into 1 plus c equal to 0, or 2g plus 2f plus c is equal to minus 2, equation 2. And since it is passing through a point 2 comma minus 1, if I substitute 4 plus 1 plus 4g minus 2f plus c equal to 0, or 4g minus 2f plus c is equal to minus 5, equation 3. And again, as it is passing through the point C 3 comma 2, if I substitute 9 plus 4 plus 6g plus 4f plus c equal to 0, or 6g plus 4f plus c is equal to minus 13. Now, I will solve these equations 2, 3 and 4 to find g comma f comma c values. From 2 and 3, it is 2g plus 2f plus c equal to minus 2, 4g minus 2f plus c is equal to minus 5. If I subtract these two, minus 2g plus 4f is equal to 3. One equation. And again, from 3 and 4, what is 3? 4g minus 2f plus c equal to minus 5. 6g plus 4f plus c equal to minus 13. If I subtract, minus 2g minus 6f is equal to 8, or yes, as it is I will keep 6. From these two equations 5 and 6, if I take 4f plus 6f, 10f, 3 minus 8 minus 5, f is equal to minus 1 by 2. Because f equal to minus 1 by 2, if I substitute here, from equation 5, minus 2g plus 4 into minus 1 by 2 is equal to 3 minus 2g minus 2 means is equal to 5, or g is equal to minus 5 by 2. Now, I got g value and f value. I need c from any of these equations. I will use equation 2. From equation 2, 2g plus 2f plus c equal to minus 2. 2g is minus 5. 2f is minus 1 plus c equal to minus 2. Therefore, c equal to 6 minus 2 means 4. Therefore, now we know g value, f value and c value. Hence, we can write equation of circle as equation of circle x square plus y square 2g minus 5x 2f minus y plus c means plus 4 equal to 0 by using this general method. Means I have taken equation of the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0. Substitute first point to get relation in terms of gfc, second point to get relation in terms of gfc, third point in terms of gf comma f comma c, and of course, if you solve these three equations, you can find g comma f comma c. But remember, while solving, you should be very careful. If one simple addition or calculation mistake means the values may go wrong. Therefore, final equation is x square plus y square minus 5x minus y plus 4 equal to 0. We will solve same problem by using other method. Let it be a 1 comma 1, b 2 comma minus 1 and c 3 comma 2. What is the method I am going to use? I will find perpendicular bisector of this and perpendicular bisector of AB also, and let that point of intersection S I will take, and I will solve to find center of the circle. So, because it is the perpendicular bisector, let me take a D and it is E. What are D coordinates you see? 5 by 2, comma 1 by 2, and E coordinate if you see 3 by 2, comma 0. Now, for equation of ds, slope of ds, because ds is perpendicular to this, it will become minus 1 by 3. Therefore, equation of ds, y minus 1 by 2 is equal to minus 1 by 3 into x minus x1 means 5 by 2, or 2y minus 1 by 2 equal to minus 1 by 3 into 2x minus 5 by 2. This 2 will get cancelled. 6y minus 3 equal to minus 2x plus 5, or 2x plus 6y is equal to 8 is the equation. It is equation of ds. Similarly, I will find slope of AB. What is slope of AB you see? 1 plus 1 2 by 1 minus 2 minus 1, it is minus 2. Therefore, slope of bisector ES, it will become 1 by 2. Hence, equation of ES is y minus 0 is equal to 1 by 2 into x minus 3 by 2, or y is equal to 1 by 2 into 2x minus 3 by 2. It is 4y equal to 2x minus 3, or 2x minus 4y minus 3 equal to 0. Let it be second equation. Now, what are these two? These two are two perpendicular bisectors, means these two are lines passing through center. If I solve this 1 and 2, I can find x comma y, which is a center. Now, from 1 and 2, what is the first equation? 2x plus 6y minus 8 equal to 0. Second equation 2x minus 4y minus 3 equal to 0. Subtract 10y minus 5 equal to 0. Therefore, y equal to 1 by 2. Now, x value from 1 or 2, from 1 I will take 2x plus 6 into 1 by 2 minus 8 equal to 0. 3 times 2x is equal to 5, or x equal to 5 by 2. Therefore, center of the circle is 5 by 2 comma 1 by 2. Now, center we know that is 5 by 2 comma 1 by 2. Let us find radius of the circle. Radius is equal to AS, which is equal to square root of distance between A and S, 1 minus 5 by 2 whole square plus 1 minus 1 by 2 whole square, which is equal to square root of 2 minus 5 means 9 by 4 plus 1 by 4. It is equal to root of 10 by 4. It is equal to root 5 by 2. Therefore, equation of circle is x minus 5 by 2 whole square plus y minus 1 by 2 whole square is equal to root 5 by 2 whole square. It is what radius. That is x square plus y square minus 5x minus y plus 25 by 4 plus 1 by 4 minus 5 by 2 equal to 0. It is x square plus y square minus 5x minus y. Here if I take LCM 4, 25 plus 1, 26 minus 10, 16, 16 by 4 plus 4 equal to 0 will be the equation of the circle. You see, Either use that method or this method, we will get a same equation only, x square plus y square minus 5x minus y plus 4 equal to 0. Yes. Now, we will try to find equation of circle by using family of circles method. Family of circles means I will take A here and I will take B here and I will find equation of circle with A comma B as ends of diameter, and I will find equation of the line also. It is L equal to 0 and it is S equal to 0, and I will write S plus lambda L equal to 0. And if our required circle is, and of course passing through this A comma B also, if somewhere here if it is C is there whose coordinates are 3 comma 2, I will substitute here to find value of lambda. That is the technique here. First, let us find equation of circle with capital A 1 comma 1, capital B 2 comma minus 1 as ends of diameter. X minus 1 into x minus 2 plus y minus 1 into y plus 1 equal to 0, or x square plus y square minus 3x, there is no y term, plus 2 minus 1 equal to 0, or x square plus y square minus 3x plus 1 equal to 0. It is what our S. And I will find equation of AB. A coordinate 1 1 to B coordinate 2 comma minus 1, y minus 1 equal to minus 2 by 1 into x minus 1, or y minus 1 equal to minus 2x plus 2, or 2x plus y minus 3 equal to 0. It is our L. Now, family of circles S plus lambda L equal to 0. Our S, x square plus y square minus 3x plus 1 plus lambda times 2x plus y minus 3 equal to 0. Let it be 3. Now, to find a required circle, it is passing through the point C 3 comma 2. I will substitute to find value of lambda. 9 plus 4 minus 9 plus 1 plus lambda times 6 plus 2 minus 3 equal to 0. This 9 cancel, it is 5 plus lambda times 5 is equal to 0, therefore lambda minus 1. Substitute this value of lambda here. Therefore, from 3 equation is x square plus y square minus 3x plus 1 minus 2x minus y plus 3 equal to 0, or x square plus y square minus 3x minus 2x minus 5x minus y constant plus 4 equal to 0. Therefore, it is the method by using the technique that family of circles. What we have done here, see, I have taken these 2 points A comma B. First, I wrote equation of the circle with these 2 as ends of diameter, which is, I am denoting it as S. And again, I wrote equation of line AB by using that line formula, y minus y1 equal to slope into x minus x1, and notation for this I have taken L. Family of circles is S plus lambda L equal to 0, I have taken. I want this lambda value. How to find here? Our required circle is passing through the other point, third point 3 comma 2, substituted this point and I got lambda equal to minus 1. Therefore, lambda equal to minus 1 you take here, then equation of a required circle is x square plus y square minus 5x minus y plus 4 equal to 0. Not only these 3 methods, any of the methods which we have discussed you can use to find equation of the circle passing through these 3 points. Other methods I hope you can try at home. You please try those methods so that at any point of time, any concept or any method definitely will be helpful for us to do or to attempt a problem in the circles. And today we have seen notation of the circles. I mean, what are the notations we are using in these circles, and some methods, I mean family of circles we have seen, and different methods when 3 points are given, how to find equation of a circle we have seen. And in the coming class we will see equation of tangent concept, and equation of normal, and some problems related to them we will see. Till then, take care and thank you.